Okay, let's talk about graphing trig functions. Now, I am quite aware, just like when we did polynomials and rational functions, that graphing calculators exist and computer programs exist that graph these things way more accurately and way quicker than we do. But it is an integral part of learning how these functions really work to break it down, and the best way to break it down is to actually graph a picture of them. So let's get started. Okay. So let's start off with the graph of the sine function. So let me show you what the graph of the sine function looks like. And keep in mind, I'm not a great drawer. I'm not expecting perfection from you. Please don't expect perfection from me. All right, so the sine of the graph function starts at 0, 0, and I'm only going to draw one period. Remember that these functions are periodic. So there's one period of the sine function. Now let's just get some important details over here. So we've got the domain, and remember we talked about this in the last lecture, that the domain of the sine function is all real numbers or negative infinity to positive infinity because there's no denominator in the sine function. What goes along with domain is range, and the range of the sine function is between -1 and 1, and you can kind of see by the curve here that that's going to run between, well, that's really not in the right spot. Again, doesn't have to be perfect, but so this would be 1, and this would be -1. Okay, now what are the other details that we should keep in mind? That this is an odd function, and because it's an odd function, we talked about that last time, but also because it's an odd function, we know that it's symmetric about the origin. Okay, another thing that we need to know about graphs is x-intercepts, right? So x-intercepts, where do the x-intercepts occur? Well, the x-intercepts occur at every power of pi. So x-intercepts happen at k pi, comma 0, where k is an element of the integers. Remember that means that for every whole number, positive or negative, you could plug in there, and that's going to give you an x-intercept. And then when we're talking about graphs and we talk about intercepts, we also need to talk about the y-intercept, and the y-intercept here is at 0, 0. Okay, now let me put some details in over here on our graph. This is one period, and so another thing that's important for us to know about them, and I forgot to write it down over here, but is the period of the graph. And one period of sine is 2 pi. That means, the period means that every possible output and every possible input for that function happens between 0 and 2 pi. Okay? All right, so let me get over here and put a little details in here for us. This is one curve, which means it is one period, so that means that this place right here has to be 2 pi. And if that is 2 pi, then halfway through is going to be pi. Now, halfway between 0 and pi is going to be pi over 2. And halfway between pi and 2 pi is going to be 3 pi over 2. And these are, and of course this is 0. So this is 5 values on the graph of the sine function. Okay? Okay, and just to go on just a little bit about it, these are actually very specific values. And this relates to the chart, actually. So let me kind of show you. I'm just going to put some some dotted lines that you can't see very well, but I didn't want to disturb the graph too much. Now, each one of these areas represents quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4. Now, let's connect this to something that we've already been studying, which is this all students take calculus thing. Now remember what this little tool reminds us of. It reminds us of where the functions are positive. And the A here in the first quadrant means all functions are positive. That is for all. S is for sine and its reciprocal cosecant. T is for tangent and its reciprocal cotangent. And C is for cosine and its reciprocal secant. Okay, so just reminding you here. Now let's relate this back to the graph. Okay, so you see in quadrant 1, all are positive. All right, cool. Quadrant 2, look, all the values of sine are above the x-axis in positive y territory, so all of the values are positive. In the third quadrant, only tangent is positive. That means that the sine values are negative, and look, it's down here in the negative area. And finally in quadrant 4 also down in the negative area. Okay, so that kind of like knits these couple of ideas together. All right, let's look at the graph of the cosine function. Now the cosine is the exact same shape, but it's shifted over. So it starts at 0, 1. It comes down, goes back up, and it ends. And again, this is one period of it. I'm just going to put that 2 pi there just for funsies, and I'm also going to list this as 1 and this, which I know is not really to scale, but when you're hand drawing it, you can make it to scale. 1 and -1. Okay, well, let's run down the details here. The domain of the cosine function is just like the sine function, -infinity to infinity. Why? Because there's no denominator. The range is also the same, and you can kind of see that by looking here at the picture. All the values run between -1 and 1. The period, and I know I'm doing this out of turn, but this is the way I wanted to do it to begin with, is 2 pi, which means every value in that range is in a range of x values that is 2 pi in length. We also need to talk about our x-intercepts. And x-intercepts happen at all the odd multiples of pi over 2. So we would say 2k minus 1 pi over 2, comma 0 is all the x-intercepts where k is an element of the integers. And we talked about this notation last class. And the y-intercept here, as you can see, is 0 and 1. Okay, let me put in some values here. And just like we did the values before, and this is going to become a theme, you start with the end of your period, and then you work backwards, okay? Don't mark your graph and then try to fit your curve into it. You draw your curve and you fit your values of the graph into it after the curve has been drawn. So 2 pi here is going to be pi. That means that this place here is pi over 2, and this place here is 3 pi over 2. And just like before, and I just want to point it out one more time, we can see here, let me break it up, I lost my pen, there it is. Into the quadrants, and you can see that this is Q1, Q2, Q3, and Q4. And going up here and taking a look, it says that everyone is positive in quadrant 1, check. Only sign is positive in quadrant 2, check it out, we're down here in the negative numbers. Only tangent's positive in quadrant 3, check it out, here we are. And cosine is positive in quadrant 4, and there it is. So this table totally gets you there. Okay, so let's graph some of these. Oh, not yet. We have some more things to do. Let's get a theorem in, and let's understand a little bit more about the period and the amplitude and stuff. So let's have this theorem here. For y is equal to a sine omega x, and y is equal to cosine a cosine omega x. If omega is greater than 0, the amplitude and the period of sine and cosine and their cofunctions are given by this formula here. The amplitude is the absolute value of the a, which is the leading coefficient, right? The number in front of it all. Okay, and then the period is 2 pi divided by omega. And so how do we get omega? Omega is all the stuff with the x inside the argument. Okay, for tan and its cofunction, the period is pi over omega, not 2 pi, it's just pi over omega. And the amplitude is the same. So let's just find the amplitude and the period of a few examples here. So this first example, the amplitude is 2. Now what the amplitude does is it stretches the y values. Okay, so with the amplitude being 2, we can talk about what that's going to do to the range. The range is now going to go from -1 to 1. It's going to now be -2 to 2 because everything has been stretched by a quantity of 2. All right, let's find our period. The period is equal to 2 pi divided by everything here but x. So omega is equal to pi over 2. So this would be pi over 2. Now we'll do that work. 2 pi over 1 times 2 over pi. Canceling out. Here our answer, our period is 4. That is the number 4, not 4 pi. Straight up the number 4. All the pi's canceled out. Okay. Let's do the next one here. Our amplitude here is 1/2, and what that's going to do is it's going to change our range to -1/2 to 1/2. So it shrunk our graph down, and our period is equal to pi over, remember it's pi, only pi for the tangent, pi over, and what's with that is 3. Okay? Let's have you get a you-do in, and we'll do a few more that are a little bit more difficult. So I'll give you about, I don't know, about 30 seconds here. Maybe only 20 seconds. Okay, so the amplitude here is 2. Remember that this is the absolute value, so the negative has nothing to do with the amplitude. It will have something to do with the graph. Remember when you're graphing a polynomial, or say a quadratic, say x squared, right? If there's a negative in front of it, it flips over. So that's going to be the same kind of situation here with our trig functions, and this changes the range to be -2 to 2. All right, and then the period here is 2 pi divided by, and what is the number here? That is 1/2. So that makes the period 4 pi. The pi didn't cancel this time when we flipped it over. Okay, let's do a few more here. Gets a little bit, you know, it's good to have several examples of this. So here our amplitude is 1, which means our range is just going to go from -1 to 1. And I'm just writing this just to reinforce it. It's going to become important later. And then, let's see here, our period is equal to 2 pi divided by pi. So our period's just 2. Awesome. Here, our amplitude is 1/7. So that means that our range is going to go from -1/7 to 1/7. Boy, that's going to be a little bitty, teeny tiny little squish little. Anyway, sorry about that. And the period here is cosine, so we use 2 pi over our omega, and our omega is 7/2. So when we do that work, we get 4 pi over 7. Couple more and then I'll give you the last two to do. So the amplitude here is 6, which means that the range is going to go from -6 to 6. And here our period tangent means that we're going to go pi divided by 2/3. So that's pi over 1 times 3 over 2 is 3 pi over 2. This last one here, the amplitude here is 9/5, which means that our range is going to go from -9/5 to 9/5. And our period, I'm dealing with sign here, so we've got 2 pi divided by 3 pi over 2. Leaves us with 4/3. Okay, I'm going to leave these last two for you to do. And I'm going to give about a minute for you to do these. Okay, so for the problem on the left here, -3 cosine of 4x, our amplitude is 3, which means that our range is going to go from -3 to 3. Our period, because we're dealing with cosine, is 2 pi divided by, in this case, 4. So that means our period is pi over 2. Remember, please simplify everything down to the most simplest. And finally, y is equal to -4/3 tan 3 pi x. Our amplitude is going to be 4/3. Our range, what is our range for the tangent function? I don't know why I'm crossing that out. I wrote those brackets in, but the range here is -infinity to +infinity. I can't believe I made that mistake over here. So let me correct it. I just fell right into it. But the range for the tangent function is -infinity to +infinity. So if you were yelling at the recording going, I don't understand, sorry, I caught myself. Okay, so this is what the range here is. Let's find our period. The period, because we're dealing with tangent, is pi divided by whatever omega is here, and here it is 3 pi, so our period is 1/3. Okay. All right, so let's actually graph, not just talk about it. All right, so the directions here are to graph 2 periods. Rarely do you only graph 1 period. You usually are asked to graph 2 periods. You want to indicate the amplitude and the size of the period and note 5 points on the x-axis, okay? More points is good, at least 5 points. If we were not in an online class, we would have face-to-face exams, and this is exactly what I would be asking for you on the exam. So let's get busy here. Let's get our info, and our info we need to know is our amplitude is 3. That means that our range is going to go from -3 to +3. We also can make note that we have a negative here, so we're going to have to flip our graph over. I'm sorry that this is the first one that I'm doing, but I didn't pay attention to that when I put this together. So nothing else here. And then finally we need to find our period. And because we're dealing with cosine, it is 2 pi, and omega here is 1. So there's our whole period. Okay. Now, what you do first is you draw the graph, 2 periods of the graph. And because we're going to start, because this is negative and we have a flip, I'm going to start down here. And I'm going to draw 1 period and 2 periods. It's not great, but it's good enough for government work, all right? Now, if it is 2 periods and a period is 2 pi, then this place right here is 4 pi. This guy is 2 pi. Now, I'm going to hit up like all the high notes here. But let's go ahead and put in our y values here. And notice I didn't go necessarily any bigger or any smaller. This is 3 and this is -3. And I'm going to indicate a few other things here. So if this is 2 pi, then this is going to be pi. This is going to be 3 pi. Okay, so that gives us our 5 points because this is 0, of course. But let me go a little bit further there and let me hit up these x-intercepts. Check them out. These are the x-intercepts, aren't they? They're where the graph crosses the x-axis. So this is at pi over 2. This is at 3 pi over 2. Next one, because it's all the odd ones, will be 5 pi over 2. And finally, 7 pi over 2. Notice I didn't do any calculations or whatever. I know what the odd multiples of pi over 2 look like. So if I was to draw out 4 periods here, we could just go right along and just write down what all those values are. Okay? Awesome. Let's do another one. Here we have the sine function. Awesome. We have amplitude of 4, which means that our range is going to go from -4 to 4. We have a period here of 2 pi divided by, and here we have 1/2. So 1 period is equal to 4 pi. All right, let's graph her up. So sine starts at 0, 0. I'm just going to draw one round. Oops, sorry, it got ugly. I will redo that, but my policy is only to redraw one time. If the second time's crappy, the second time is just going to look crappy. Okay, so here we go. Oh, good enough. I'll extend that line on out there. And this is 2 periods. So 4 pi for 1 period, this will be 8 pi. So that means whether it looks like it or not, this is 4 pi. That means between 0 and 4 pi, this is 2 pi. Between 4 pi and 8 pi, this is 6 pi. Now notice what has happened to the x-intercepts. It's not every multiple of pi. Now, it is the even multiples of pi. Just on this as a side note, these x-intercepts are 2k pi, comma 0, where k is an element of the integers. That means even multiples of pi. Okay, let me get a few other values in here as well. So that means this guy is pi, this guy is 3 pi, this guy is 5 pi, this guy is 7 pi. And that pretty much hits up all the, and of course this is 0. That hits up all the important stuff. Now let's go ahead and also put in our y values here. So this is 4 and this is going to be -4. Okay, so you see the way to do this is a little bit backwards maybe from the way that you've graphed other things. We know what the shape of these look like, and we know that they're periodic, so they're not squished in. We know that they're going to be the exact ratio of the lengths between the important points in the graph. Okay, cool. Let me do one more and then I'll give you one to do. So let's take a look at this guy. Now, this is where trig gets a little bit on the tricky side. This negative sign goes away because cosine is even, right? So this kind of becomes a plus. In fact, it just pretty much, let me use this white here if I can find it. I can't use the white because I can't see it. There's the black, so I'm just going to cross it out. Now maybe I can use the white and color it over. Nope, anyway. Okay, stop, Heather. Okay, thank you. All right, thanks. Okay, let's get the important stuff here. The amplitude. Here the amplitude is 1. That means that the range is going to go between -1 and 1. And the period is 2 pi over 2, which is pi. We're drawing cosine, so that starts up here on the y-axis, and I'm going to draw 2 periods of it. So there's 1, and there's 2. At this point here, this is 2 pi because we need 2 periods. That is 2 pi, making this spot right here pi, making this spot right here pi over 2, making this spot right here 3 pi over 2. So you can see it's kind of compressed. And now our intercepts aren't happening at the pi over 2's, but it's actually happening here. This is pi over 4. This is 3 pi over 4. This is 5 pi over 4. This is 7 pi over 4. So if we wanted to say that, we could say that the x-intercepts here, and I'm focusing on x-intercepts because they're super important, right? Because x-intercepts are solutions. They're zeros, they're roots, they're the solutions. So we want to focus in on these x-intercepts. So the x-intercepts, if we wanted to write this, would be, they're the odd multiples of pi over 4. So that's going to be 2k minus 1 pi over 4, comma 0, where k is an element of the integers. This is the odd multiples of pi over 4. That's how we write that. Okay? All right, so I'm going to leave you do this one. I want to remind you that that negative changes this because that guy is odd. So we get to pull that sign outside. So you go ahead and do this. I'm going to give about a minute and a half. Okay, so this time the amplitude the same, the period the same. Now what we do have is a flip. Okay, so we're going to start and go down instead of up. Starting at 0, we're going to draw our 2, 1, 2. There's our 2 kind of cruddy periods, but that's okay. There's our 2 pi. That means that this guy is pi. That means that this guy is pi over 2. That makes this guy 3 pi over 2. Ooh, look how interesting this has gotten. Okay, and then in between here, this is going to be pi over 4. It's going to be 3 pi over 4. is going to be 4 pi over 4. This is going to be 5 pi over 4. 6 pi over 4. 7 pi over 4. There's our, in the middles, our important ones there. What is our range? Oh, I see I forgot to do it over here too. All right, fix that up. Now, how can we talk about the x-intercepts here? Well, we have, let's take a look. It's not the odd multiples of pi over 2 because we have pi over 2 and then pi and then 3 pi over 2 and then 2 pi. And then if we were going to go on with this, we were going to extend it. The next one would be 5 pi over 2 and then 3 pi. And then it would be 7 pi over 2 and then 4 pi. You can extend the pattern out and kind of look at it to kind of see. How could we rewrite that? Well, how can we rewrite 3 pi? Well, that's 6 pi over 2. 4 pi is 8 pi over 2. So really what we have here is all the multiples of pi over 2. So k pi over 2, where k is an element of the integers. And I'm going to write that here as all multiples of pi over 2, and you need to remember that multiples of pi over 2, and I'm just going to write a little example here, is we've got pi over 2, and then we have 2 pi over 2, and then we have 3 pi over 2, and we have 4 pi over 2. So that does include those whole numbers, right? Because if the k is even, then the 2 is going to cancel. Okay, cool. Let's do another one here. Graph 2 periods and indicate the amplitude period and 5 points on the x-axis. I was crazy with all of these, flipping them over. I'm going to change this to just a plus. I'm tired of flipping them over. My prerogative. All right, so we're going to get our amplitude, and our amplitude here is 2, which means our range is going to go from -2 to 2. And our period here is 2 pi divided by 3. Ooh. Exciting. We're going to have to do some math over here on the side to figure out all of our stuff. All right. Let's graph it first. It's the sine function, and we're graphing 2 periods. Sine functions start at 0, 0. So there's 1 period and 2 periods. Good enough for government work. Now, the period is 2 pi thirds, and if we are having 2 periods of that, multiply that by 2. This is 4 pi over 3. Now, don't start panicking. I'm not going to do every possible value here, but I am going to do all the intercepts, okay, because those are super duper important. All right, so if this is 4 pi over 3, half of that is going to be 2 pi over 3, right? And let me just write in this other stuff so I don't forget, because I tend to forget that. Let's write this is 2 and this is -2. Now, to find our stuff in the middle, we're going to actually need to do a little bit of work. Okay, so what is between 0 and 2/3, or in other words, half of 2/3? So 2 pi over 3 divided by 2, so half of it is going to be 2 pi over 3 times 1/2 gives us pi over 3. So half of 2 pi over 3 is a pi over 3. So if that's half of it, and that's one of those sections, if one of those sections is pi over 3, to find this spot right here, we can do one of two things. What I'm going to do is I'm going to say 2 pi over 3 plus a pi over 3, because each one of these sections is worth a pi over 3, and that's going to give us 3 pi over 3, which is just pi. And so this spot here is just pi. Now, we can find them in between, and I'll just find a couple of them, but frankly, once you find the ones here, you can just apply it by adding it through. Let me show you. So what is half of pi over 3? So pi over 3 times a half is pi over 6. So this is pi over 6. If that's pi over 6, that's 1 pi over 6. That makes 2 pi over 6. This would be 3 pi over 6. And 3 pi over 6 is pi over 2. So this guy would be pi over 2. This is 4 pi over 6. And 2 pi over 3 is equal to 4 pi over 6. So that's cool. So that makes this guy 5 pi over 6. That makes this 6 pi over 6, which we know is equal to pi, so yay on that. Then that makes this guy here 7 pi over 6. So we can easily find all of those values without doing a whole lot of math. We had to do a little bit of math, but not a whole lot of math. Okay, and just for the giggles of it all, let's write out those x-intercepts, because it is so important that you know what they are. And the x-intercepts here appear to be all the multiples of pi over 3. So I'm going to give you a second, maybe about 15-20 seconds for you to write down how you would write that mathematically. Okay, recall this is not odd ones, this is all of them. So this is the least complicated of them. It's going to be k pi over 3, comma 0, where k is an element of the integers. Now notice I write that every time. It is very important. You must write it every time. Math is tricky, and you have to be really, really clear about what you're doing. All right. Now, what I have done so far is just kind of giving you little nibbles. Everything's been kind of pretty. It's the same way as when you started learning how to graph, say, quadratics, right? First, you just graphed stuff that was nice and pretty, x squared. And then it was like 3x squared, so you expanded it up. And then it was 3x squared plus 2, and so then it was shifted. Then it was 3 times x plus 1 squared plus 2, and then it was shifted over and up. That's where we're going. Now you know how they basically work. Let's be able to shift them around and do some other things. So this is actually the standard form, and this applies, and I only wrote it in sign because I didn't want to have to write it in 6 different ways, but this applies to all the trig functions. Okay, doesn't have to be sine. It applies to all the trig functions, including tangent, cotangent, cosecant, and secant. Okay, so this is very similar, and I'm going to bring you back to maybe a shot from the past, but this is very similar to the standard form of a quadratic equation, right? And this is something that you learned how to do real quickly on how to shift things over. We're talking about a horizontal shift, we're talking about a vertical shift, and we're talking about stretches or shrinks or flips, okay? Where the A indicates stretches or shrinks or flips. The H was the horizontal shift with that permanent negative sign inside, which meant that you ignored the negative when he determined whether it shifted to the right or shifted to the left. And then that outside of the function plus or minus that indicated that vertical or horizontal shift. We have the exact same thing here. Okay, the A is our amplitude. If it is negative, it indicates a flip. The period, depending on whether you're dealing with a sine, cosine, or a tangent, and their cofunctions are either going to be 2 pi over omega or pi over omega. The pi over omega only happens for tangent and cotangent. This is all the others. The vertical shift is the V and the phase shift is the H. Now, if you recall, also, when you were doing this thing with the quadratics in your college algebra class, the other very important thing is it had to be in that form. It had to fit that form. Must be in the form. In fact, you probably learned how to complete the square or something, some other kind of trick to turn that into a squared binomial. Okay, so that's the same situation here. We must have the equation in the specific form to determine the phase shift, and this is the form. Okay, so we have to factor out the coefficient of the x. So to get it in the form, factor out the coefficient of x, whatever that is. Okay, so let's take a look. All we're going to do is determine the amplitude and the period and the shifts of these examples here. All right, so first let's do our amplitude. Okay, and the amplitude is 2/3, and we know what that does. That makes our range go from negative 2/3 to positive 2/3. Okay, let's find our period. Omega is always the number in front of the variable, so you can find the omega before you find any of the phase shift because it's just always going to be that coefficient of the variable. We're dealing with sine here, so it's going to be 2 pi divided by 3. Let's do our horizontal shift. Oh, I meant vertical shift. Sorry. Let's do our vertical shift, and then I'll do our horizontal shift, which is called the phase shift, but that's horizontal. But let's do our vertical shift. In this case, there's no number added or subtracted out here, so there is none. And then finally, let's do our phase shift. And the way we're going to do our phase shift is we're going to take the argument, so just the argument. We only handle the argument, and we're going to factor this 3 out. So if we take a 3 out of an x, we get a 3x. If we factor 3 out of pi, we're left with pi over 3. So the equation here can be rewritten as y is equal to 2/3 sine of 3 times x minus pi over 3. And there is our phase shift. And so our phase shift just like when we did this stuff with the quadratic equations, is you ignore the negative sign, so the phase shift here is going to be in the positive direction, so it's going to be right pi over 3 units. Okay? All right, let's do this next one here. Okay, here our amplitude is 1, which means that our range is going to go from -1 to 1. Cool. Our period here is 2 pi divided by the number in front of the x, our omega, which is 2. So our period is just straight up pi. Vertical shift. We do have a vertical shift here, and it is down 3 units. And then let's figure out what our phase shift is here. So we're going to take the argument 2x plus 3 pi over 2, and we're going to factor this 2 out. Now, listen, I don't expect you to really maybe be perfect at doing this, so I'm going to really break it down for you, okay? Factoring out the 2 means that we're going to divide each of these things by 2, okay? So if we divide the 2x by 2, we're left with an x. If we divide the 3 pi over 2 by 2, we're left with 3 pi over 4. You're going to have to do some fraction work. If you're not great with fractions, you're going to have to do some fraction work here, okay? So this equation can be now rewritten as y is equal to the cosine of 2 times x plus 3 pi over 4. So that helps us see here that our phase shift is left because it's positive. So that is indicating a negative 3 pi over 4. Left, I don't know why I put colon there, 3 pi over 4 units. Right? So let me do one more, and then I'll give you an example. This is kind of a long lesson, just so you know. There's a lot to do here, so you might want to, actually, I might break it into 2, to be quite honest with you. I think I will. Okay, so let's finish this up in the next slide, I think, and then I'm going to end this one, and then I'm going to break this into two separate recordings. If not, your eyes are going to glaze over and you're just going to like hate yourself. Okay, so here, let's do this one. The amplitude for our tangent of 5x minus pi over 2, the amplitude here is 1. That means the range goes from negative infinity to positive infinity because it's tangent. Okay, our period is pi over 5 because it's tangent, it's pi. Vertical shift, none. And let's see what our phase shift is going to be. Let's do the work over here. We have 5x minus pi over 2. So if we factor out the 5, we're going to be left with x minus, dividing that by 5. is pi over 10. You can always check it by multiplying it back through really quickly. 5 times x is 5x. 5 pi over 10 is pi over 2, so you know that you've got it. Now you don't necessarily have to rewrite the function. I just have been rewriting the function so you could just see it like that. So I'm going to, again, tan of 5 times x minus pi over 10. So our phase shift here is right because it's not a negative number. That negative is permanently built into the general form, so right pi over 10 units. Okay, and then let me give you this you do to do. I'm going to give you about a minute, minute and a half. Give me the amplitude, the period, the vertical shift, and the phase shift. Okay, if you're not done, please just pause so you can check yourself. The amplitude is 4/3, so that means our range is going to go from negative 4/3 to positive 4/3. Our our period, talking about cosine here, so that is going to be 2 pi divided by the number in front of cosine here is 1/2, so our period is going to be 4 pi. Our vertical shift is up 2 units. And let's see what our phase shift will be. Taking our x over 2 plus 3. Okay, now you might have been like, oh my gosh, why does she give us one that's so hard to do? No, we're going to follow this same idea. What is the number with that x? That's 1/2. So we're going to factor out 1/2. When you take 1/2 out of x over 2, we're left with x plus divide 3 by 1/2, and that is equal to 6. So this equation here, and I'm just going to make a note that we'll need to flip this guy too because of this negative. We'll write this as y is equal to negative 4/3. Good thing this is just about it. Negative 4/3 cosine of 1/2 x plus 6 plus 2. So our phase shift here is to the left 6 units. Okay, so let's graph 2 periods here with this vertical shift. Okay, now a couple things I want to point out is it's not going to change the shape of the graph. All right. And that I wish I had not drawn this middle line. Okay, so this x-axis that I have here is just going to serve as something that kind of holds our place, and then I'm going to draw in the appropriate x-axis. So this is just basically a placeholder. Okay, you'll see what I mean when I get going here. Let's get what we need here. Our amplitude is 2. That means we're going to go from -2 to 2. Our period is equal to 2 pi divided by 1, so 2 pi. There is no phase shift. But we do have a vertical shift of up 2. All right. So what we want to do is we want to just go ahead and draw our curve. Our period here, let's go ahead and put that in. It's 2 periods, so that's going to be our 4 pi. That's going to make this guy 2 pi. I'm just going to jot those in there. Okay. Now, how do you handle the vertical shift? The way that we do the vertical shift is to focus on that range. So right now, the range is going from -2 to +2. But if we add in that vertical shift, which is up 2, we're going to add 2 to both of these guys, and our new range is going to be from 0 to 4. So what I'm going to do is I'm going to draw in our x-axis. This is 0, this is 4. And if I hadn't put that line in there, I would have lightly drawn in one, and then I would have erased it, or, you know, whatever, so that you could see it. But you can see now how that would go. Hopefully you see how that will go. Okay, I'm going to do this last one because I need to just line this up, and then I'm going to make a part 2 of this and get that posted for you as well. All right, so let's do this last one here. Our amplitude is 1. That means that our range is going from -1 to 1. Wait, notice I don't have any phase shifts going on here. Those are a little bit harder to graph, and I'm not going to get into that too much. Our period, because we're dealing with sine, is 2 pi divided by 4, which makes it pi over 2. We have a vertical shift of down 1. Okay, so let's get started. Just the same darn way, we're going to consider this x-axis here just a guide, and then we're going to draw in our new x-axis. This is sine, so it starts at 0, 0. Let's draw 2. Our period was pi over 2, so pi over 2 times 2 is just pi. So this guy is just pi. This guy is pi over 2. Oh, I realize I didn't do my 5 points on the x-axis there, but if you'll notice that they're going to be, sorry. We'll write that up in a second. I'm sorry, I got super distracted because I am done. So, all right, it's the last one. Let me get it together. Okay, so here is our graph. Let's go ahead and find the rest of these points here. If that's pi over 2, then this is going to have to be pi over 4. If that's pi over 2, then this is 3 pi over 2. This guy is 0 if we wanted to be so inclined. This guy would be pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8. So I'm going to keep on doing that because once you see that pattern and really see it, then it just really makes your life so much easier. So there that is. And then what we need to do is we need to handle that vertical shift. And the vertical shift here is down 1, so we start off with our negative 1, 1, and just like over there we added 2, here we're going to subtract 1. So this is going to go from negative 2 to 0. So that means that there's our x-axis. This is 0. And this is a negative 2. And there's our graph. Okay, let's write out those x-intercepts also, just because I really want to be consistent with that, because it really helps. Our x-intercepts here are, looks like pi over 4, 2 pi over 4, 3 pi over, might be a little bit too tired for this. Let's see here. Pi over 2 and 0, pi and pi over pi half. Oh, it's because that's the 3 pi over 4. You guys might have been screaming from the void on that too. That's a 3 pi over 4. Now we got it. Okay, so the x-intercepts appear to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. The x-intercepts are all the multiples of pi over 4. Okay, is an element of the integers. And then we're just going to hop over here because I just didn't finish this one over here. I know I have 5 points technically, we had it, but let's go ahead and get those x-intercepts. So this guy is going to be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, and then 7 pi over 2. And if we want to describe those x-intercepts, which I do love, this looks like odd multiples of pi over 2. So this is 2k minus 1 pi over 2, comma 0, where k is an element of the integers. Okay, yay. All right, so this is the end of part 1. There will be a part 2, and that we will do the tangent function, the cotangent function, the secant, and the cosecant. All right, thanks. Y'all have a good one.